the part on metrics, the goal GAS assessment. And because we are also interested in the repeatability of experiments, and I'd like to know whether you have experience in this. With the difficulties that you've had, and I know that some tasks the children will learn, and I'd like to know whether that metrics, especially coming back to what Fabio said, how can you quantify the difficulty of the task and how to assess the results, especially in order to measure whether the methodology employed, be it a robot or whatever, has achieved the improvements that we're pursuing. Well, that was something that we were really looking for, because we developed a robot, a sensor, an interface, and it does work. And okay, even in my PhD thesis, I have a model, the robot, the controller, etc., which I haven't shown you here. So everything is there. But the question is, how can I show, how can I demonstrate that the child has learned? And how can we quantify all this? And it was very difficult to obtain a metric. So we came up with this GAS, which is the only one that we have managed to develop. There was literature where this matrix was used, and we use the same correlation index, because so far we didn't have time to work on that index, because why 0.3 instead of 0.5? And that's the metrics. And the metrics involves lots of information. You need to include statistics or a term based on your experience by observing if the child is happy. And that is. But that's what the matrix is about. For the teachers, this is an exceptional work, but for us, we are engineers, and what we want is figures and numbers to be able to compare things and make sure that they work. So this was the only matrix that we have developed. So it would be a good piece of work to propose another matrix or another matrix. We have been searching intensely for this, but it seems to work. We have managed to explain why it was achieved. The very image of the movement of the robot can help us identify the mistakes. For example, mistakes need to be written on a whiteboard, so we can digitize the image and then calculate the mistake. But then things work well at first with the children, then they take the robot, and then they come back, and then they take a different road. And of course, this is big mistakes for the robot. The issue is knowing whether they have attained the goal or not, good or bad, but how good or how bad, +1 or +2. So even if I have the number for the mistake or the error, and how long did it take, and then we have to calculate the time. Well, thank you very much. I wouldn't like to close the session without first congratulating the members of the panel, and also acknowledging how difficult it is to propose this kind of real experiment with children with cognitive problem, because of the difficulties it entails. So we're aware of the fact that you had to struggle for this. And if you allow me, I'd like to say some final words to highlight the role of robotics and the different technologies involved in the development of robotic solutions. And we have heard 3 papers with a common denominator, that of empowerment, the empowerment of the user's capacity. And we are trying to improve the interaction of the user and the robot by improving the communication channels and improving the flow of information, which is necessarily involved in this physical and cognitive interaction, looking also for the matrix and the technologies which would help us compare the different empowerment technologies. The need to apply learning techniques to recover autonomy. So this is technology which is now available, but of course taking it to market will necessarily go through making the products more usable, more easier to control, and now we're trying to improve the learning part by incorporating learning techniques such as the one commented upon by Professor Miguel Ángel Rodríguez Román on genetic algorithms to try to apply them on a person who has lost the skill of walking. So when the person interacts with the robot, and the robot interacts with this skeleton, so that each individual can eventually recover his own skills. So we can use a low-cost mobile robot to help children who have motor problem instead of setting them aside, and thus help them improve their cognitive skills. And I think that all this in line with the objectives of this project and this conference in general. If there's any question, it will be welcome, and if not, we are going to now close the session. Thank you very much.